Hello everyone, my name is Vicente Otaegui. I'm a sixth-year student in civil engineering from the Universidad de los Andes. This presentation is about my professional practice done in the year 2023. I worked for APSA, a prestigious Chilean company founded in 1996 which delivers infrastructure management services, mainly focused on road studies and pavement analysis. The projects I worked for were mainly focused on pavement analysis using advanced equipment capable of measuring multiple indicators on the road. The device shown is called LCMS laser. APSA was the first Latin American company providing this type of technology. The non-invasive laser is capable of measuring IRI, International Roughness Index, agüeyamiento, which is the depression on roads generated by the constant passing of vehicles, and agrietamiento, which is the formation of cracks on the road. My work during my practice was mainly the filing, creation, and improvement of data, using tools such as Excel, Google Earth Pro, and some of the company's own software. The most challenging part of my practice started by generating 4 text files using the company's software for processing the LCMS laser data device. This machine delivers an XLM file for each measurement. I was asked to do this for highway intersections. Using an XLM file for each highway and the software called LCMS Result Parser, I was able to obtain 4 text files. Each one then had to be converted onto an Excel file and transferred onto a macro-enabled Excel sheet from the company's own Excel files. Then, when the macro ran correctly, it generated a fifth sheet called Promedios 10M, which contains left, right, IRI values, left, right, routing values, texture values, and its corresponding coordinates in latitude and longitude, along with its own phase number. Once this data was created, I had to look on another Excel file called Anexo Evaluación Funcional IRI, which had information about the section in study, specifically the part in which it started and ended to be able to match its IRI value correctly. For example, as shown in the image, Calle de Servicio Los Arrayanes starts at 88,400 and goes to 89,100. To recognize the start of this section, I had to look at the KMC files I previously created. Using the coordinates, it could be determined at which phase the section really started. The case shown starts at phase 0, but will not always be the case, so it must be analyzed on its own. This image contains the last 2 values of the IRI average values for Calle de Servicios Arrayanes. 3.87 corresponds to 3.9, and 4.49 corresponds to 4.5. For the cracking process, things were different. There are 9 values for cracks: longitudinal, transversal, and crocodile cracks. Crocodile cracks are the ones shown on the right. Each one of these 3 types of cracks was divided into 3 more called low, moderated, and high. Longitudinal cracks were obtained from a file called lit, also transversal cracks, and crocodile cracks were obtained from a file called fat. These values were then pasted onto this sheet called comp, which is the one shown in the image. The amount of time it took me to complete the information for a single road section or intersection was considerable and made me pursue more optimal ways of completing this. The amount of Excel files I had to open and close every minute was immense, so maintaining a clear, organized, and descriptive process was essential to complete each file as fast as possible, leaving no room for mistakes. So with this in mind, I created a system. I did everything in the same exact order. This led me to the creation of helping sheets that contained automatized formulae, which then I just transferred onto the Excel sheet I was working on. Another problem I encountered was many sections did not have any information, so I then had to report this to my superior. Finally, when I had all the files, I had to check them many times and then send them to my superior alongside the report with every conflict I encountered. Thank you for listening.